We're looking at the very first question of the 2018 Higher Paper 1. And as soon as you look at it, it's a bit mean for a first question, but actually you probably do know what to do. So just stay calm and watch this. Here we go. So we've got the cube root of 64 times 1,000. Now you may not remember that actually you can split that into the cube root of 64 times the cube root of 1,000. The cube root of 64 is 4. And you are supposed to know the cube roots. You're supposed to know the cubes and the cube roots all the way up to 10 cubed. And there's a clue because this one, cube root of 1,000, is 10. So what we've actually got is 4 times 10, which is 40. So a question that looked really nasty isn't that bad at all. Question 2. Again, looks quite worrying, but let's have a look at it. The vector -2, 3 translates A to B. So let's do a little sketch. We'll call that one A. Now, according to this, it's going -2 in the x direction, so it's going over there, and then it's going up 3. So B would be there. So we've gone across 2, up 3. It's only a sketch, remember. Now we've got to translate B to A. So what would we do to get to A from B? Well, we'd go over 2 in the x direction, but down 3. So which one of those shows that? It's that one. Question 3. Circle the expression that is equivalent to 3a minus a times 4a plus 2a. Now, this is where we have to remember BIDMAS, and so we can see that there's a multiplication which will have to be done first. A times 4a is 4a squared. 3a minus 4a squared plus 2a. So that's going to be 5a minus 4a squared, which is that one there. Question 4. Circle the number that is closest in value to that. Let's see, let's do a bit of rounding. That's going to be 10. And this I'm going to round to 0.02. So we've got 10 divided by 0.02. So I'm going to write this again here. 10 divided by 0.02. Now the reason I've put it here is just to show you that actually I don't want to divide by 0.02. What you can do is multiply both elements by 100. 10 times 100 is actually 1,000, and 0.02 times 100 is 2. And now we've got 1,000 divided by 2, and the answer to that is, of course, 500. And that is the answer. You don't have to divide back down. So long as you multiply both parts, we could do the same thing here. Multiply both parts by 100. So there's 1,000, and there's 2. So we can see it's 500. Question 5. Solve this here. So let's multiply out the brackets first of all. Actually, I'm not going to multiply out the brackets first of all. I could have done, but I've chosen actually to divide both sides by 5. The left-hand side becomes x plus 3, and that is less than 12. So I don't need the brackets actually, so x plus 3 is less than 12. Take 3 off both sides, x is less than 9. Now you might want to check that that works. So let's say that x is 8. 8 plus 3 would be 11. 5 11s are 55, which is less than 60. So x is less than 9. Question 6. The height of Zach is 1.86 meters. The height of Fred is 1.6 meters. Write the height of Zach as a fraction of the height of Fred. That means we are putting 1.86 over 1.6. The height of Zach as a fraction of the height of Fred. We're going to get an improper fraction. That's fine. Let's multiply both the numerator and the denominator by 10. So we've got 18.6 over 16. Well, actually, let's multiply by 100. So multiply by another 10 again. So we've got 186 over 160. And now we're going to simplify. I'm going to divide them both by 2. So we're going to have 93 over 80. And that has to be our final answer. So in the answer block, that's what we're going to write. 93 over 80. The height of Zach as a fraction of the height of Fred in its simplest form. Okay, question 7. A is at 0.2, B is at 6.5, and they're points on the straight line ABCD. It says that AB is equal to BC, AB is equal to BC, and that's equal to CD. Work out the coordinates of D. Okay, well, let's consider how would we get from A to B. We would go 6 in the X direction and 3 in the Y direction. So let's go to C. We're going 6 in the X direction, so that's going to be at 12, because we know B is at 6. And we're going 3 up from 5, so that's going to be at 8. Remember, the diagram is not drawn accurately, so that's why it looks strange, because that's at 2 on the y-axis, that's at 5 on the y-axis. So there we are, there's the 3 up that we went. We're going across 6 again, so that's going to get us to 18. And we're going up 3 again, so that's going to get us to 11. So the coordinates of D are 18, 11. Question 8. A coin is thrown 50 times, it lands on heads 31 times. Write down the relative frequency it lands on heads. Now there is a bit of a clue here. Write down. Usually if it says write down, it means that the answer is there in front of us, which it is. It's 31 out of 50. That's the relative frequency of it landing on heads. Part B. Raj says the coin is biased towards heads. Use the data to give a reason why he might be correct. So you've got to give an explanation such as we would expect the relative frequency to be 25 out of 50, which is a half, but it is higher than that, so it may be biased. Question 9. The range of a set of numbers is 15 1/4. The smallest number is -2 7/8. Work out the largest number. Well, I would like a number line here, so I'm going to draw one just there. There's 0, and the smallest number is there, which is -2 7/8. The range is 15 1/4. That means the difference between the biggest and the smallest is 15 1/4. So actually, the range is that much. So we've got to find that distance there, because that's going to tell us where the largest number is. And we can do that by saying we've got 15 1/4 as the full range. Let's subtract the 2 7/8. So 15 1/4 subtract 2 7/8. And it's probably going to be easiest to convert these to improper fractions. So 15 times 4 is 60, plus 1 makes 61 over 4. Subtract 2 8s is 16, plus 7 is 23, 23 over 8. We want the denominators to be the same, so we're going to make them both 8. So this one's going to be 122 over 8, double 61, double 4, minus 23 over 8, and that is going to give us 99 over 8, which is a top-heavy and improper fraction, of course. So now let's change that to a mixed number. That is going to be 12 3/8. So there's our answer. Put it on the answer line, 12 3/8. Question 10. Y is inversely proportional to X. Complete this table. Well, I'm going to do it the old-fashioned way and say, well, if it's inversely proportional, it's going to be Y equals K over X. We've been given a value of Y and X, so we can put 4 in for Y and 6 in for X, so we can see that K is 24. 4 6 is 24. So Y equals 24 over X. So when X is 12, Y will be 24 over 12, which is 2. And when Y is 8, 8 equals 24 over X. Swap those two over, X equals 24 over 8. X is 3. Question 11. A large rectangle is made by joining 3 identical small rectangles as shown. So 3 identical small rectangles. The perimeter of one small rectangle is 15 centimeters. work out the perimeter of the large rectangle. Well, one of my students said to me it's like a logic problem, and that's exactly how we should view it. It's just a puzzle to solve. It says the perimeter of one small rectangle is 15, so I'm going to pick that one there, and if I call that side x, immediately, because the rectangles are identical, we can see that that must be x for that one, and that must be x as well, which means that that side is 2x. So we can say that side is 2x, and of course that is x. And so now we know that we've got, starting there, x plus 2x. So along there, down there, across there, another x, and up there, another 2x. So altogether that's 6x, and we've been told that 6x is equal to 15, which means that x must be 15 divided by 6, and that is 2.5 centimeters. And now we know what x is, we can look at the whole shape. We know that that must be 2x to match that one because they're identical. So all the way around, that's going to be 3x plus 2x plus 3x and another 2x. And that comes to 10x. X is 2.5, so 10 lots of 2.5. 10 times 2.5 equals 25. So the answer is 25 centimeters. Question 12. Put these numbers in order from smallest to largest. So we've got 8 times 10 to the minus 4. So you probably know that you can just write 0.123 4. 4 times 10 to the minus 2, 0.12. 6 times 10 to the minus 4, so 0.1234. And 0.07 is already in this format for us. The easiest way to compare them is to make them have the same number of digits. So if we put 2 zeros there and 2 zeros there, and then if you hide the 0.0 in each case, you've got 008, you've got 400, 006, and 700. And looking at it like that, you can see that the biggest one is going to be that one. The smallest one is that one. We can write 6 times 10 to the minus 4 in the smallest. 0.0008 has got 2 more in that column than that one, so it must be that one next. It's a little bit bigger. This one is really quite big in comparison to those two, so that is 4 times 10 to the minus 2 and 0.07. So we've written them exactly in the format that they were presented to us. Question 13. Circle the volume that is the same as 15 cubic centimeters. Well, let's look at 1 cubic centimeter. One little cube, 1 cubic centimeter. You will remember that a centimeter, that distance there is 10 millimeters, and that's 10 and that's 10. So let's just draw that out. Here's that little cube, and that is 10 millimeters. That is 10 millimeters. And the height is 10 millimeters. So the volume of that little cube, let's just make that a bit clearer, is 10 times 10 times 10. 10 times 10 times 10, and you know that 10 cubed is 1,000. So we've got 1,000 cubic millimeters in that cube there. So if we've got 15 of those, we must have 15,000. There it is. Question 14. Patterns are made using straight lines, there's the straight lines, and arcs, those little curves, arcs. So in pattern 1, we've got 1, 2, 3, 4, 5. So let's put straight lines. We'll put 5. The S stands for straight lines. I could have written L, but I wrote S. Let's write A for arcs, and there are 8 of those in pattern A. Pattern B, there's 2 rows in here. You can see that there are 10 straight lines. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 arcs. So I'm going to write this again down here. I'll write S and A again. And we've got in the first pattern, so pattern number 1, we've got 5 straight lines and 8 arcs. Pattern number 2, we've got 10 straight lines and 12 arcs. And we are looking to get the number of straight lines to the number of arcs to be 10 to 9. Well, that one clearly can't be. Although it's got a 10 there, the ratio is certainly not 10 to 9. I think what this does tell us, though, is that the number of straight lines will be a multiple of 10. So let's keep going. Pattern 3, that's gone up by 5, gone up by 4, not a multiple of 10. Pattern 4, that's going to go up by 5, so that'll be 20. This one's going up by 4, so that'll be 20 as well. Pattern 5, that's going to be 25, that's going to be 24. Pattern 6, that's going to be 30, that's going to be 28. So 3 10s are 30, but 3 9s, that's what we're looking for. 3 9s are not 28, they're 27. And we're looking for that relationship. Okay, pattern 7 is 35, and that'll be 32. Pattern 8, that's going to be 40, because it's 4 more than that is 36. So we've got a multiple of 10. Let's check this then. 4 10s are 40, 4 9s are 36. Yes, there is the pattern. The number of straight lines compared to the number of arcs is in the ratio 10 to 9. Now the question said, how many rows are added? Because at the top we've got as far as pattern B, which I'm calling pattern 2. There's pattern B. Perhaps I should have called them A, B, C, and so on, but never mind. There's pattern B. So we have added 1, 2, 3, 4, 5, 6. We've added 6 rows. Right, 14b, a different pattern is made using 20 straight lines and 16 arcs. So it's a completely different pattern. The straight lines and arcs are made from metal. 20 straight lines cost £12. The cost of one straight line to the cost of one arc is 2 to 3. Work out the total cost of the metal in the pattern. This is the type of question where you look at it and you think, I've got no idea, I don't know where to start. Think about it, let it mull around in your brain for a minute. They've told us that 20 straight lines cost £12. Well, let's find the cost of one straight line. So we're going to do £12 divided by 20. Well, £12, of course, is 1,200 pence. Dividing that by 20, we can remove a 0 from each. So we've got 120 divided by 2, which is 60 pence. That's the cost of a straight line. The arc is 2 to 3. So if 60 pence is sort of 2 shares, then 3 shares will be 90 pence, because 2 30s make 60, 3 30s make 90. So the ratio of the costs is 60p to 90p. Now we know we've got 20 straight lines, so we know that 20 times 60p is £12, because they've already told us that anyway. Now all we need is 16 times 90p. So a bit of working out over here. I will do it this way up. Although 90 is a larger number, by doing it this way up, I can simply put a 0 straight in there. 6 9s are 54. 1 9 is 9. Add 5 makes 14. That is £14.40. Remember, that was 90 pence. And in pounds, that's £14.40, which I'm putting straight under there. And we can add those straight up. So 42, add 4 is 6, 1 and 1 is 2. The total cost is £26.40. So a very unpleasant looking question actually isn't too bad at all. Question 15. A biased dice is thrown. Here are the probabilities of each score. The dice is thrown 200 times. Work out the expected number of times the score will be odd. So odd numbers are 1, 3, and 5. So if we add up those three, 0.25, 0.15, and 0.3, just add those up. Put a 0 there if it's easier. 5 add 5, a 0 there, 1 there. 1 add 3 is 4, 5, 6, 7. So the probability of getting an odd number is 0.70, 0.7. So we've got to do 0.70 times 200. Now the easy way to do this is to say, well, that's 0.7 times 2 times 100. So use that 100 to move that. 100 times 0.7 gives us 70. 70 times 2, we would expect 140 times to get an odd number on this biased dice. Question 16. The value of y is 20% more than the value of x. Circle the ratio x to y, and then we've got 4 choices. Okay, Well, if it's 20% more than the value of x, we could write a little equation y equals 120 over 100 times x. Having got that, let's simplify it. First thing, just cross out those zeros. So 12 over 10 times x, which is actually 6 over 5 times x. That means that y is 6x over 5, multiply across 5y equals 6x. They haven't left us much space here. I'm going to write it down here now. So they want the ratio x to y. So I'm going to write 6x equals 5y. Now the way I'm going to do it is divide both sides by y. So 6x over y equals 5. And now I'm going to divide both sides by 6. So x over y equals 5 over 6. And we can express that in a ratio form. X to y equals 5 to 6. So that's the answer there. Only 1 mark for quite a lot of thinking. Now, question 17. Here is a triangle. Circle the correct equation, and they've given us a choice of 4. Well, you've probably guessed that we're going to need to use the sine rule. So let's look at the sine rule. A over sine A equals B over sine B equals C over sine C. But remember, all of those can be flipped up the other way. So you could have sine A over A equals sine B over B equals sine C over C. Now let's look at the information we've got. Let's give the triangle some letters. I'm going to call that one A, that one B, and that one C. Now you can see from C that it hasn't got an opposite side given to us. We're not really interested in that part of the equation. So we're only looking at the A's and B's parts. Let's try them in there. So x is a length over sine 42. X over sine 42 is equal to 15 over sine 104. Oh, and actually, we've got it straight away. It's that one. It couldn't have been that one because that said sine x. Well, x is a length, not an angle. Similarly with that one, it couldn't be that one because x is a length and not an angle. And if we look at this one, we've got the x over sine 42 is right, but then the 15 over sine 34, the 15 has to be opposite the angle that we are using, and it's not, it's adjacent to it. So that one doesn't work. So there we are. This is a 5-mark question. Here is a tunnel for a toy train. The diagram below shows the cross-section of the tunnel, so what the end of it looks like. And you can see they've labelled it A, B across there and C, D across there. So that's A, B, C, D. And that outer arc, that outer semicircle, has a radius of 10 centimetres. The inner semicircle has a radius of 7 centimetres. They're saying AD is a semicircular arc of radius 10 centimetres. BC is a semicircular arc of radius 7 centimetres. And the length of the tunnel is 30 centimetres. Work out the total area of all 6 faces of the tunnel. They're not asking for the volume, they're asking for the area of all 6 faces. So let's try and work out what those faces are. We're looking for the area of the foot of the tunnel there and the foot of the tunnel there, but also then the inside curved part and this outside curved part. It's like there's a sheet of paper over the top of there, and we've got to find the area of it, and a sheet of paper stuck on the inside of there, and we've got to find the area of that, and the arc at each end. Let's do the feet first, because I think that's going to be easiest. This foot here is 30 centimetres long, and it's 3 centimetres wide. So 3 times 30 is 90 square centimetres. So that's that foot. I'm calling that face number 1. Face number 2 is the other foot. So that's going to be the same because it's still 3. 3 times 30 is 90 square centimetres. So we've got 2 of the faces already. Now it's going to get a bit harder because we're looking now for the area of this. Now the area of that is, well, let's pretend it's a complete circle. Not very good drawing there, but if it's a complete circle, so there's the circle in the middle and we want the area of that. So if we find the area of that whole circle minus the area of that circle and then halve it, or find that half first and then subtract that patch out of it. So the area of the whole circle would be pi times 10 squared, which is 100 pi, but we've got to take away pi times 7 squared, which is 49 pi, taking away all of that from all of that. So we're left with 51 pi, but that would be the area of the whole circle. We only want half for this one, but actually we want the other half for the other end of the tunnel. So we'll stick with 51 pi, so that's 3 and 4 together. So what's really quite an unpleasant question, it seems, well, it's getting easier. So far we've got the area of that foot, the area of that foot, and the area of those two faces. Now we need the area of the top sheet of paper, if you like, if it's going like that around the top of it. The area of that is, if we could sort of unwrap it, we would have a rectangle that is 30 centimeters that way, and the other length of the rectangle is half of the circumference of the circle. The circumference of the circle, as you know, will be 2 times pi times the radius, but we only want half of it, so it's going to be pi times the radius, which was 10, so 10 pi. That is the length around there, a half of 2 pi r. 10 pi times 30, so we've got 300 pi. 3 and 4, remember, were 51 pi. The outer surface is 300 pi. Inner surface, this sheet of paper here, so using the same principle, it's going to be a rectangle that is 30 centimeters long, but how wide is that rectangle? It is a half of the circumference of that whole circle. So 2 times pi times r, but we only need pi times r because we only want half of it, so that is 7 pi. 30 times 7 pi is 210 pi. The total area of all 6 faces is this lot added together. So that is those two, which is 180 square centimeters, plus 300 and 210 is 510, 561 pi square centimeters. So let's write that again. 180 plus 561 pi square centimeters. Question 19. Type A batteries and type B batteries were tested. The cumulative frequency diagram shows information about the battery life of type A. Cumulative frequency, battery life. Estimate the interquartile range for type A. Looking at the graph, we can see that there were 80 type A batteries, because that's the very top of it. Halfway to 80 is 40, so that's there. Halfway to 40 is 20. This is what we really want, because we're looking for the lower quartiles. Drawing across from there to the graph, so that's 1100 hours. And the upper quartile, there's halfway, look at 40. The upper quartile is there at 60. The upper quartile, of course, is halfway between the median at 40 and the total at 80. So coming down from there, we've got 1400, we've got 1100. That's the lower quartile, that's the upper quartile, lower quartile, upper quartile. So the interquartile range is 1400 minus 1100, so that's 300 hours. Part B says, estimate the number of type A batteries that had a battery life of more than 1600 hours. More than 1600 hours, there's 1600 hours. So if we go up to the graph from there and go across from there, we get to there, and look, there's 70, 72, 74, 76, 78, 80, about 76. So there are just 4 batteries that had more than 1600 hours, because there's 76 up to 80, so it's 4. Right, here's question 19C. The box plot shows information about the battery life of type B. On average, which type had the greater battery life? Tick a box. Was it type A or type B? Use data from both diagrams. State how you chose your answer. On type B, we can see that the median was 1300. There's the upper quartile there and the lower quartile there, but I'm going to use the median at 1300 hours. Let's look back now at type A. Let's go across from 40 and come down to the graph from there. Now let's look carefully at this. That's 1200, that's 1300. So I'm guessing each of these is 20. So 1220, 1240, 1260, 1280, 1300. So it's looking like 1260 or 1260 hours for A was 1,260, B was 1,300, so I'm saying type B, and I've got to state how I chose my answer. So the median number of hours for type A is 1,260. The median for B is 1,300. That's all that's needed. Question 20. A linear sequence starts a plus 2b, a plus 6b, a plus 10b. The second term has value 8. So there's the second term, and that's worth 8. The fifth term, which we haven't got yet, has value 44. Let's find the fifth term. So each one, it appears that a is not changing. So a plus, there's the fourth, there's the fifth. 2b to 6b is 4b. 6b to 10b is 4b. So we're adding 4b every time. So that looks like that's going to be 14b. So that one will be 18b. So now we know that a plus 6b is equal to 8. And a plus 18b is equal to 44. Now you might be recognizing that these are in fact simultaneous equations. So let's call that one A and that one B. And because B has the larger figures in it, and also because there's just A on both of them, I'm going to do equation B, subtract equation A. Let's write B again here. A plus 18B equals 44. And we'll write A again here. A plus 6B equals 8. And then we're going to do B, subtract A. But of course, A take away A is 0, so we don't even need to write anything down. 18B take away 6B is 12B. And 44 take away 8 is 36. So B must be 36 divided by 12, which of course is 3. If we substitute that value into equation A was A plus 6B equals 8. Now we know that B is 3, so we know that A plus 18 equals 8. Now I'm going to subtract 18 from both sides, so A equals 8 minus 18, which is of course minus 10. A is minus 10 and B is 3. Question 21. Enlarge triangle ABC by scale factor -2, center 4, 1. So they've shown us where the center is, 4, 1. There's the triangle. And it says scale factor -2. Now the negative means it's going to be the other side of the center of enlargement, and it's going to be flipped over. The 2 means it's going to be twice as big. So BC, for example, is going to be, instead of 1 square wide, it's going to be 2 squares wide. What we're going to do is draw these lines through here, through the center of enlargement from each corner. And if you look at point B, it's 2 down, 2 across. So through the center of enlargement, we're going to go 4 across and 4 up. So actually, I think my line wasn't drawn carefully enough. I think it should be probably there. If you look at C, that's 2 down, 3 across. So we're going to go 4 up, 6 across, which will get us to there. So again, my line is not terribly well drawn. And this is quite tricky when you're trying to go through the center of enlargement with the lines. You've got to be a bit more fussy than I was then. And A was 4 across, so it's going to be 8 in the opposite direction, which takes it to there. But now let's join those 3 points and see how it's looking. And it is 2 wide. It is the same shape, but flipped and twice as big. And we really should label the points of the new triangle. That's matching to A, so that's called A dashed. Going from B to there, that's going to be B dashed. And C is to there, so that is C dashed. Question 22, we have to identify which of these represents the shaded region. Circle your answer. So we've got that one there. That's A with the intersection of B dashed. That means everything that's outside B. B dashed is everything outside B. So there's B dashed. That's everything outside B. So B is that circle there. Everything outside of that is B dashed. A union of B dashed, that is actually the one that we want because it's everything that's in A united with, I always think of union as united with, joined with everything that's outside of B. So that it includes that area there. So it is that one there. Question 23. A shopkeeper compares the income from sales of a laptop in March and April. So the price is a fifth more than March in April, and the number sold is a quarter less than March. By what fraction does the income from these sales decrease in April? So we know the income's gone down. By what fraction has it gone down? Now, I'm going to pick on a price in March. So let's say the price in March was £100. Quite cheap for a laptop, but let's say that. And the number sold in March, well, let's say it was 4. So in March, 4 lots of 100, the sales value, £400. Now, the price in April is a fifth more than March. A fifth of 100 is 20. So in April, the price is 120. It's gone up by £20. But the number sold in April is a quarter less than March. So a quarter of 4 is obviously 1. The number of sales must be 3. The sales value would be 3 lots of 120, which is, of course, £360. The decrease is £40, and we have to compare that to 400. So 40 out of 400. The sales value in March was 400. The decrease is £40. So 40 out of 400, obviously we can just cancel out those zeros. So it's 4 over 40, which is 1 over 10. So the fraction, by what fraction does the income from these sales decrease in April? It's gone down by 1/10. Question 24a. Work out the value of 2 to the power 14 divided by 2 to the power 9 squared. And that bit is squared and it's inside brackets, as you can see. Give your answer as a fraction in its simplest form. So we have to deal with the brackets and that index first. Now 2 to the 9 squared is 2 to the 18, because it's 2 to the 9 times 2 to the 9, which is 2 to the 18. So we've got 2 to the 14 over 2 to the 18. So you will remember as well, I'm sure, that if you're dividing indices, then you are going to subtract. So we've got 2 to the negative 4. Give your answer as a fraction in its simplest form. So that's 1 over 2 to the 4. But 2 to the 4 is, of course, 16. So the answer is 1/16. Question 24b, work out the value of 25 to the power 3 over 2. Now the easy thing here is always to look at the number at the bottom. 25 to the power of 1/2 simply means the square root of 25, which of course is 5. And then you cube it. So the 2 at the bottom is showing us that we find the square root, and then we have to cube it. 5 cubed is, of course, 5 times 5 times 5, which is 125. Question 25. Here is a sketch of the graph of y equals cos x for values of x from 0 to 360. So let's have a look at the graph. 0, 360, there's x, obviously there's y, and you can see 0 degrees, 90 degrees. Have a good look at those. You know already probably that cos of 0 is 1 and cos of 90 is 0. And look, if that's 90 and that's 0, that must be 30 there and 60 there. And you will remember, I'm sure, from the 30, 60, 90 triangle, 30, 60, 90, that is 1, 2, root 3, and cos 60 will be equal to adjacent over hypotenuse, which is, of course, a half. Cos 60 is a half, and we can find that from the 30, 60, 90, 1, 2, root 3 triangle. But we can also see it, look, on the graph. If we look at cos 60 and go up to the graph, you can see that it arrives at a half. Well, that's good news, because that's what we expected. Let's go across from there. And the interesting thing is that cos 60 is worth a half, but so is cos of wherever that is. Now remember, every interval here is 30 degrees, so 270 plus 30, that must be 300 degrees. So we know that cos 60 is a half, but cos of 300 is also a half. It shows it on the graph. So part B of question 25 says that cos x is negative cos 60. Well, we know that cos 60 is a half, so negative a half is going to be there. Let's draw a line across the graph at that point, and you can see that there are two values that are going to satisfy this. But they've said work out the value of x when it's between 180 and 360. So between there and there, the only place is there, and going up to the graph, we can see we're taking 30 off 270, so that's 240 degrees. Question 26. B is 2/3 of C, and then they've given us 5a equals 4c. Work out the ratio a to b to c, and give your answer in its simplest form, where a, b, and c are integers, so whole numbers. So let's see what they've given us. B is 2/3 of c. 5a is equal to 4c. Well, I'm going to take the 5a equals 4c, and I'm simply going to divide both sides by 5. So we've got a equals 4c over 5. Now I'm going to put these in a row, a to b to c. So I'm going to write 4c over 5 to b, 2/3 of c to c, which is c itself. Now I'm going to multiply every element by 5 to get rid of that 5 down there. So if we do that, they all stay in the same ratio, but it's just getting rid of that 5. So multiply each bit by 5. That's going to be 4c. That's going to be 10/3 c, and that's going to be 5c. I want to get rid of the 3, so I'm going to multiply every element by 3. 12c to 10c to 15c. Now if we remove the c's, because they've all got c's, you can see that the ratio is 12 to 10 to 15. And if you check back, b is 2/3 of c. Well, this one was b. 10 is 2/3 of 15. 5a makes 4c. 5 12s are 60. 4 15s are 60. So it works very nicely. 12 to 10 to 15. Question 27a. Joe wants to work out the solutions of x squared plus 3x minus 5 equals 0. She says the solutions cannot be worked out because that does not factorize to that, where a and b are integers. Is Joe correct? Tick a box. Well, she's correct that it won't factorize, but I don't think she's correct that we can't find any solutions, because I'm sure you'll remember the quadratic formula. Let's see if the quadratic formula is going to work for us. With the quadratic formula, we're going to have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this formula will always work if that bit is a positive number. If that's negative, it can't work because you can't square root a negative. But if that's a positive number, it'll work. So let's just test that out. We need to see if b squared minus 4ac is positive. b is 3, so 3 squared is 9, minus 4 times a, which is 1, times minus 5. So minus 4 times 1 times minus 5 is going to be plus 20, so we get 29. It is clear that that is positive, so no, she's not correct. We can use the quadratic formula. Question 27b, without expanding any brackets, show how to work out the exact solutions of that and give the solutions. Without expanding any brackets, I always feel it's quite good to avoid expanding brackets if you can. We've got to find the exact solutions of that. So here it is, 9 times x plus 3 squared equals 4. Now if we divide both sides by 9, we're going to have x plus 3 squared equals 4 over 9. And you may notice that both of those are square numbers, so we can square root this and say x plus 3 is the square root of 4 over 9. But the vital thing to remember is when you square root something, it can be plus or minus, it can be positive or negative. For example, we could say the square root of 4 is 2 or minus 2. And so that's what we've got to remember here. So let's do this square rooting. So x plus 3 is equal to plus or minus 2 over 3. So x will be equal to plus 2 over 3 minus 3. I've taken 3 off both sides, and that will give us negative 2 and 1/3. 3 subtract 2/3 is 2 1/3, and it's a negative, of course. Or minus 2/3 minus 3, which will be minus 3 2/3. Those are the two solutions to that little equation there. Question 28. Simplify root 80 plus the square root of 2 2/9. And give your answer in the form a root 5 over b, where a and b are integers. Let's do root 80 first. So I'm going to put that over this side. And to me, 4/20 is the easiest way to split 80. So we've got that root of 4 times 20. But you might notice that 20 is 4 times 5. So I'm going to write the square root of 4 times 4 times 5, which is the square root of 4 times the square root of 4 times the square root of 5. So all I've done is split that into 3 different square roots that all multiply together to make 80. Now, the square root of 4 is 2. Square root of 4 is 2. And look, we've got a root 5. That's good news because we're looking for that. So actually what we've got here is 4 root 5. But we've only done part of it. We've done that part. So now I'm going to do the square root of 2 2/9. Well, I'm going to make that mixed number into an improper fraction. So we've got the square root, 2 9s are 18, add 2 makes 20 over 9. Now the good news here is that we've got a root 20 there, which we've seen before is 4 times 5. So we can write this out as root 4 times 5 at the top over root 9 at the bottom. Now that's root 4 times root 5 all over root 9, which of course is 3. So let's put that 3 in. Root 4 is 2, so we've got 2 root 5 over 3. So that's that one expressed like that. And we've simply got to add these together. So we've got 4 root 5 plus 2 root 5 over 3. So this one's a fraction. That isn't a fraction, so we're going to make it into a fraction with a denominator of 3. So we're going to times this one by 3 over 3. 3 over 3 times 4 root 5 will give us 12 root 5 over 3. That's this one. Pulling this one all the way down to there, we've got 2 root 5 over 3. We're adding those together, so we're going to have 14 root 5 over 3. 12 over 2 is 14. 3 is the denominator. 14 root 5 over 3. Look, A is 14, B is 3. So we better put the answer where it belongs. We're going to have 14 root 5 over 3, and it's in the form that they asked for. Question 29. Here are our sketches of 2 graphs. There's graph A, and there is another one, y equals x squared minus 1. So that's the equation for this graph here. The graph of y equals x squared minus 1 is translated 3 units to the left. So this graph has gone 3 units that way to give us graph A. Okay. The equation of graph A can be written in the form y equals x squared plus bx plus c, and we've got to work out the values of b and c. Remember from your work on functions, if we've got a function of x, and in this case, function of x equals x squared minus 1, if it's translated 3 units to the left, then 3 is actually being added to x. So we've actually got to do the function of x plus 3. And that means wherever x appears, instead of x, we write x plus 3. So here's our equation, y equals x squared minus 1, but we're going to write instead y equals x plus 3 squared minus 1. Let's multiply out that bracket. So we've got x plus 3 times x plus 3, and don't forget the minus 1 there. So x times x is x squared plus 3x plus 3x plus 9 minus 1, and that's going to give us x squared plus 6x plus 8. 3x plus 3x is 6x plus 8. So there, bx plus c, so b is worth 6 and c is worth 8. Question 29, part B. The graph of y equals x squared minus 1 is reflected in the x-axis to give graph B. Work out the equation of graph B. Let's look at the graph again for a moment. There it is, y equals x squared minus 1. That's the graph we were looking at just now. And it's reflected in the x-axis, which means it's going to be looking like that. That's just a sketch, of course, but it's just flipped over. Remembering your work from functions, if we've got f of x, there's the function of x. If it's reflected in the x-axis, then we've got negative f of x. Simple as that. So you've got f of x reflected in the x-axis, you've got negative f of x. So we've got y equals x squared minus 1. If we reflect it in the x-axis, we're going to have y equals minus all of that. So that would be y equals minus x squared. Minus times a minus is a plus, so plus 1. But it's tidier to write it out like this. Y equals 1 minus x squared. Just putting the positive at the front there. And question 30. Show that the value of cos 30 times tan 60 plus sine 30 is an integer. In other words, that somehow ends up as a whole number. Let's see how it's done. Well, let's use that 30, 60, 90 triangle again. 30, 60, 90. And that is the 1, 2, root 3 triangle, of course. Cos 30 is going to be adjacent over hypotenuse, so that's root 3 over 2. Tan 60, there's the 60, so now that's the opposite. So that's root 3 over 1. And sine 30, let's find that at the same time. Sine 30 is opposite over hypotenuse, so that's a half. Now the first thing we have to do is to multiply those two together. So cos 30, that's root 3 over 2 times tan 60, which is root 3 over 1. And you know that root 3 times root 3 gives you 3, and 2 times 1 gives you 2. So that part is 3 over 2. So we've got the 3 over 2, and sine 30 is a half, so let's add that. So now we've got 4 over 2. And of course, 4 over 2 is worth 2, which is an integer.